There's reports of a rogue DHCP server on the network. By the time we're done here, we will examine a practical scenario where Wireshark can detect and help locate a rogue DHCP server. So if you haven't run into this before, a rogue DHCP server is a really common thing that can cause a whole lot of network damage. It usually goes something like this. You've got your normal DHCP server set up in your network, which hands out IP addresses to the clients so that you don't have to manually assign IP addresses to each one, right? It's doing its thing, life is good, and then someone brings something from home, and it could be a whole variety of things that they bring to try and do something. I can't even fill in all the different scenarios that could be there inside of their cubicle. They plug it in and introduce a rogue DHCP server that starts handing out IP addresses that take your clients offline. Finding these guys without Wireshark is really tough. I'm going to show you how you can detect and figure out where that rogue DHCP server is at. Watch this. So I'm starting right here with Wireshark, but by the time you got here, you already would have gotten the trouble ticket. You know, people complaining, hey, network's down, I can't access the internet, whatever, however that comes into place, right? So I'm going to start a capture. And the first thing that you'll see is I've got a lot more traffic coming in than we did when I did my simple ARP test. I'm already up to 27 some packets. So I'm going to come over here to my network properties on my computer. Right click on it, go to properties, because right now this guy is set up for a static IP address, 192.168.2.50, because he's plugged into Nevada, which is the 192.168.2 subnet. That's fine. So I'm going to go into his settings, change him over to get an IP address automatically, which is what sets him up for DHCP. I'll click on OK. OK, it's now trying to get an IP address. Okay, fair enough. I think we're about there. Let's stop. Oh, and this is where a lot of people look at Wireshark and they're like, forget that. 927 packets, 29 packets, if to be technically accurate, that we've captured of all kinds of stuff going on. What is all? I mean, and this is not just us. We knew that we were 192.168.1.50. We saw that. I mean, this is other stuff. This is a production network. Welcome to the problem that everybody has with Wireshark is it gathers all the data, good and bad. So what I'm going to introduce right now in this practical scenario is not just Wireshark capturing data, but how you can begin using filters. If you can't filter, you can't do hardly anything in Wireshark other than weed through thousands and thousands of packets that come out every single minute. We know that there's a problem with DHCP, and one of the simplest filters that we can create is simply typing in the protocol that we want to see. DHCP. That's the name of a protocol. I hit enter and shoot, it comes down and shows me exactly what I'm looking for. I see my computer right here. Now, hang on, whoa. How do I know this is my computer? Well, because I look at that MAC address and in a previous video, I saw BizLink was my MAC address, but there's my full MAC address. And if I really wanted to know, I could open a command prompt, bring that over here, type in ipconfig/all, and I know that this is my network card that I have connected. What is its MAC address? Well, it's somewhere right around, actually, where is the MAC address? Oh, right there. Physical address, 9CEB, and then just look at the last 4 characters. That's usually the unique part. FD1A, and I look back here, FD1A. See that? So I know that's me. I'm sending out a broadcast because that's the first thing that a DHCP client will do is try to send a discover. Now, look at the time. Within less than a second, maybe half a second, actually maybe a second and a half, the DHCP server responds and is like, hey, I got an offer for you. As a matter of fact, if I span that out, I can see that it's trying to offer me 192.168.2.4. Isn't that interesting? We can even figure out what the offer is. And then my computer replies back and says, yeah, request. I will take your offer. Yeah, I saw that the requested IP address is right here. And notice it's also saying, and I see that you are 192.168.2.1. There's the DHCP server. So it's asking for that. And then the DHCP server responds back and it's like, okay, ACK. That means I got it. Acknowledged. That's now your IP address. You're good to go. But look at what's right after that. Just a moment later, another DHCP server responds on the network. It's like, hey, I'm 192.168. 1.1. Whoa, wait a sec. My subnet is 2.1. That's probably from somebody bringing in something from home, because 192.168.1 is the typical home subnet that people use in their environment. So this DHCP server is trying to offer me, notice the offer right here, 192.168.1.208. That's not good. Now, this one comes back after a little while, and it's like, okay, NAC, meaning a negative acknowledgement. I'm not going to do that, because I've seen that right here a broadcast was sent that you were taking the other one, but forget all of that. First off, two things. One, just by looking at Wireshark, you learned a little bit about how DHCP works, right? But two, we discovered the rogue DHCP server on the network. This is the good one. This is the bad one. We were very fortunate in this case that the bad one is probably a home router. And by the way, it is. I set up this little rogue environment over here. The home router is way slower than my production Cisco router. So just because my production router was faster, it responded in a second or so. The home router took about 3 seconds to respond to that request. My client took the best one first. But if somebody brought in a rogue DHCP server that was a lot faster, the other ones would get that request first, right? And that's when they start dropping off of the network. Now, what's furthermore? Who is this rogue DHCP server? Well, if I come down here, I can see that the server itself is 192.168.1.1, and that's helpful. But if I scroll back up to the top, notice right there, aha, there's the MAC address. This is, again, layer 2 information, layer 1, layer 2, layer 3, there's our IP address, right? Right there, there's the MAC address of that rogue DHCP server. And as a network admin, now I've got the liquid gold that I can use to track that person down. Now, we haven't gotten into it yet. Let me show you. I'm bringing up a telnet prompt to our Nevada switch because I want to show you a command. We'll learn this command later on, but it is show MAC address dash table. And I can hit the enter key, and I can see every MAC address that this guy has learned since it's been online. Now, you're like, oh, man, that's a lot to troll through. And you're right. So what I can do is I can go right here and go, okay, last 4 characters are 5C68. So I come back up here, hit the up arrow, do show MAC address table, and I'll put a little pipe symbol right there. I know, pipe, where's that? It's on the keyboard right above the enter key. And I can say include, oh, I forgot the MAC address. What was it? 5C68. 5C68. Enter. Bam! Look at that. It says, I see your MAC address. I got your MAC address right here on Gigabit Ethernet 0/2. And as a network admin, you know what I do? Come over to the switch that I see this connected, and I go, oh, there's Gigabit Ethernet 0/2. Let's follow that cable. And it won't take long until I find out where that cable goes and the rogue device that's there. What I do after that is how good my karate moves are. We've now examined a practical scenario where Wireshark can detect and help locate a rogue DHCP server. I hope this has been informative for you, and I'd like to thank you for viewing. Ninja!